Let's continue our discussion about TFA. So in this video lecture, we're going to focus on determining the accepted strings of the given automaton. So let's start with example 1. So we have 4 states. So the first 3 states are final state, while the fourth state is a trap state. Why can we consider this as trap state? So after the first 3, when it goes to, okay, to this trap state, okay, so it will not move anymore to another state. So after 0, it will just loop within this, okay, within this state. So which pattern will go to this trap state? So by disregarding some loops, so the result is 1, 1, 0. It means if the string contains 110, it will go to a trap state. Therefore, the accepted word is, or the accepted string is, word or string does not contain the substring 110. Okay? If we have 110, it will be go to the trap state. So example 2, we have 7 states. The first 6 are final state. Regardless the value of the symbol, it will proceed to the next state. And after the sixth state, it will be on this state, which is a trap state. Again, this is a trap state because this is not an end state or a final state, but when the string reach to this state, it will just loop within itself. It will be trapped by this state. So what what string can be accepted by this automaton? So an empty string could be accepted. It will be on this final state, A. If we have one length 1, it will be accepted based on this. Length 2 still accepted. Length 3 still accepted. Length 4 still accepted. Length 5 still accepted. So therefore, from 0 to 5 length is accepted. So the rule would be a word or a string which has a length of at most 5. It will be accepted. More than 5, it will be rejected. Example 3. Okay, so we have 3 final state and 2 non-final state. So if we have 1, it will go to this final state. By the way, if it's an empty state, it's still accepted. So 1, go to this. But if we have another 1 after 1, it will go to a non-final state. And if we have another 1, it will go to another final state. But after this, okay, after the 1, 1, series of 3 ones, if we have 0 for this state, it will go to this final state. And if we have other values after this, after the second non-final state, it will go to this final state. And anything go to this final state will just loop within itself after going to this final state. So based on this, which string will not fall on our final state? Okay. So in this example, disregarding this final state, so a string which is equivalent to 1, 1 or 1, 1, 1 will fall to a non-final state. So therefore, those are the strings which are not accepted. So our rule is any string except 1, 1 and 1, 1, 1, and the rest will be accepted. Okay. Example 4. So we have 5 non-final state and we have 1 final state. So what will be the pattern? Okay. So as you can see here, we have 0, 0, 0. for this path. And then it will go to the next if we have encountered 1. And then loop, loop, loop 1. Then if we encountered 0 after 1, it will go to the final state and then loop. While for the second branch, if it encounters 1, it go to this state. And if this state still encounters 1, just loop within itself. But if we have 0, it will transmit or go to the next state. And then, as long as we have 0, loop, 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 loop. And then if we have 1, it will go to a final state. So when will we have a transition? So in this part, there will be a transition if we have 0 to 1. And this part, 1 to 0. This part, 1 to 0. And this part, 0 to 1. So based on that analysis, the string should have 0 and 0, 1 and 1, 0 as substring so that it will be accepted. If not, it is rejected. Okay, 0, 1, 1, 0, go to final state. Final 1, 0, 0, 1, final state. Okay, so that's it for DFA. Thank you for listening. See you on the next video lecture. Thank you.